welcome to our YouTube channel. We are working on a series of videos on openmp, and this is our 11th video on that series. If you haven't checked out the previous ones, do watch them to get a better idea of openmp. And without further ado, let's get right to the content. So today we are discussing atomic construct. So it is quite similar to the critical construct, but it's a little different. It's very subtle. The difference is very subtle between critical and atomic. So pragma omp atomic, that's the statement that we have to write to initiate the atomic construct. Ensures that a single memory update is performed automatically. So we are doing, that's a typo actually. What I meant to say was automatically. So how is it different from the critical construct? Well, in critical construct, each thread was updating the construct here, but in this case, the update happens automatically without the thread's interference. So as you can see, we have pragma omp parallel for, and then pragma omp atomic. So this program is very subtly different. I'll show you the comparison as well, and let's head to the live demo as well of this program. So first of all, this is the atomic program for the atomic one, and I have the program for critical as well. I'll open up. Yeah, you see, thread added to this. Very subtle difference. The only thing is I have removed this line, printf statement, because now there is no thread is updating this. This update happens automatically. So as soon as the thread encounters this block, this part will be updated automatically without the thread's interference. So, okay. So what are we? So I am currently logged into a HPC Param Rudra, and I am inside the login node, and I have loaded a module called Intel 1 API compilers for the openmp that I will require. So let's compile the program, and then we will discuss the other things. Okay, let's do atomic.c. I need this connector in this particular server, and the program is compiled. Let's run the executable /a.out, and here you go. It gives me the final value of sum. The only update was here. So final value was printed after this. So if you may ask that why are we using atomic, why can't we just stick to critical and all of that? So atomic actually has very less overhead, so it's much more performance efficient. So whenever we are working, whenever we need the program to run faster, or we want more performance out of it, you can replace the critical construct with atomic. But there is also a catch. Atomic is not very customizable. So you can only use it for very simple tasks like sums or subtraction. That all is fine, single variable work. But critical is very customizable. You can add multiple things inside of it. And so that is why for complex programs critical is used. And for simpler programs, whenever we have a single variable function, so there we use atomic, so that the program is actually speeded up. That is it for this video. Thank you.